Today our lesson is on parallel and perpendicular lines, and I will talk through a bit of this, and there are some proofs in here that I really want to do with you in class next time, so I'll probably save those for you to give a shot to, and then we'll work them together in class tomorrow. So let's start off with another theorem that says if two lines are parallel to the same line, then they're going to be parallel to each other. That makes sense. I mean, it kind of looks like the transitive property, doesn't it? But it's not the transitive property, and you can't call it the transitive property in a proof. If you were to use this theorem in a proof, you would just say two lines are parallel to the same line. So that would be what your reason would say. But if I got P parallel to Q here, and Q is parallel to R, then I can say that P is parallel to R. Looks just like the law of syllogism and the transitive property, but it's neither one of those things, so don't call it that. The next theorem says in a plane, if two lines are perpendicular to the same line, so look here, we got M and N, both perpendicular to P, then what can you tell? You can tell that they're going to be parallel to each other. Two lines perpendicular to the same line, then they will be parallel to each other. And again, if you're using that as a reason in a proof, you can just say two lines perpendicular to the same line. Your statement would say M is parallel to N. Your reason would say two lines perpendicular to the same line. It's okay if you abbreviate it like that. And then we have this one, which does have a name, the perpendicular transversal theorem. And it says in a plane, if a transversal is perpendicular to one of two parallel lines, so in this picture here, J is our transversal, H is parallel to K, and our transversal is perpendicular to H, then we know that that transversal is also perpendicular to K. So if it's perpendicular to one of two parallel lines, then it is perpendicular to the other. Perpendicular transversal theorem. Okay, what do we have here? In the diagram below, each fence post is parallel to the fence post immediately to the right. Explain why the fence posts on each end. So why are they parallel to each other? So why is L1 parallel to L4? That's what we're trying to explain. We could do this as a proof, but we're just going to talk through it. Okay, so it's given that L1 is parallel to L2, right? They tell me each fence post is parallel to the one immediately to the right. So I know that these two are parallel. All right, I also know that L2 is parallel to L3. That's also given, right? And so now, look, I'm going to stop and I'm going to use that first new theorem that I learned. Since I know these two things, I'm going to say, therefore, L1 is parallel to L3. And remember, it's not because of the transitive property or the law of syllogism. It's because of the theorem that says two lines are parallel to the same line. And in this case, that would be L2. Okay, so I've got L1 is parallel to L3. All right, and I also know that L3 is parallel to L4, right? Because that's given. L3 is parallel to L4. So therefore, when I put these two things together, I can say L1 is parallel to L4 because of this same theorem that two lines are parallel to the same line. So they got to be parallel to each other. All right, that's how I know those fence posts on each end are parallel. Okay, here's another one. This might be, yeah, I think this is the proof that I want you to give a try to, and then we're going to do it together. We're going to talk about it in class. You're building the picture frame in the diagram below. You cut pieces of wood such that the measures of angles 1 and angle 4 are 30 degrees, and the measures of angle 2 and angle 3 are 60 degrees. So prove that the right and left sides of the frame are parallel. So, I'm going to tell you right now, these angles are marked wrong. Angle 1 is congruent to angle 4. So we're going to use different colors. Change these markings, bad markings. And I think I copied this picture out of the book. Angle 2 is congruent to angle 3. So I'm going to give you a hint on this. Okay, we can see that we've got some right angles there, right? 30 and 60, we can see that we got right angles on both sides of this frame. So that tells me that I've got some perpendicular lines there. So that's your hint. That's the hint that is going to help you prove that the right and left sides of the frame are parallel. So I really want you to give this your best shot, and then we'll go over this in class. Actually, you know what? I want you to do it, and I'm going to put it up here for you right now to check, and then we'll talk about it if you got some questions about it tomorrow. So here's how this proof played out, and I wanted to go ahead and do it for you because it's a little tricky. We've been so used to trying to show that angles are congruent and their measures are equal that I felt like it might be difficult for you not to get off track on that. But what we had to keep in mind is that what we're really trying to show is that side PS of this frame and side QR right here are both perpendicular to SR, and then by the perpendicular transversal theorem we can say that they're parallel to each other. So I really hope that you gave this a shot on your own, and then you can look and see what I did here, and hey, maybe somebody did it in a simpler way, and I'd be really happy to check that and see how it came out. But what I did is I used the angle addition postulate to show that I had right angles at corner S and corner R. And then since I got right angles, I know that that means that those two sides are perpendicular to the bottom. And that's where I said that in step 6 right there. First I had to prove that they're right angles, and you see how I did that using angle addition. And finally, in the end, then I could say that PS is parallel to QR because they're both perpendicular to it, which is the perpendicular transversal theorem. Okay, so this proof, much easier than the one above, so I definitely want you to do this one. I want you to have it on your paper so we can go over it tomorrow. I'm not going to put it up here today. And then we have a little error analysis here. Let's see. Shiro sketched coplanar lines M, N, and R. He claims that it shows lines M and N are parallel. So he's saying, okay, this is showing that these two are parallel. What other information do you need? What other information do we need? Oh, we need to know also that M is perpendicular to R, right? We got to know that M is perpendicular to R, or we don't know that M is parallel to N. Okay, and this problem here, it takes a lot of thinking, and guys, what it's going to require you to do probably is for each one of these statements, you're going to need to redraw this picture. You're going to need to redraw the ladder. So for instance, let me do one, and then again, I'm going to ask you to do the rest of these. So for this first one here, I've got a ladder, and it says I'm only going to use the statement to make some conclusions about the rungs, one side or both sides. So it says the rungs, so there are my rungs, they are each perpendicular to one side. So let's just say they're all perpendicular to that side. So what is that going to tell us? Well, of course it's going to tell us that they're parallel to each other, right? The rungs are parallel to each other. And how do we know that? Because of the theorem that says if two lines are perpendicular to the same line, then they're parallel to each other. So we're going to abbreviate it. Theorem, two lines are perpendicular to the same line. That's how we're going to abbreviate that. Okay, so I did one. I want you to do 4 more, and I do think you're going to need to draw a little diagram for each one of these. You're going to do 2, 3, oops, 4. You got 4 more. 2, 3, 4, 5, and we will check those when I see you next time.